What's going on, folks? Wanted to go over another lab walkthrough that I'm pretty much for my video diary for my CCIE Service Provider Studies. I'm currently working through the INE workbook now, and I'm going through the L3 VPN section. And my topic today is MPLS L3 VPNs with route reflection. So what I'm assuming is going to happen is that we're going to use one of the routers in the network as a VPNv4 route reflector, opposed to having to do full mesh L3 VPN um, peers between each PE. So go ahead and run through the task, and I'll show you guys the diagram. So I already preloaded my routers with all the configuration that needs to go there, so that's already set up there per the INE instructions. And then the diagram that we'll be using is this one here. We'll be working through configuring these devices. So, you know what? Just because I like to have the diagram on at least a little bit, I don't really need all that real estate to type my command. So, let's see if I can make that happen. So, let's go ahead and just clear some of this out. I don't need the command window, it's taking up a lot of space. So, this is our configuration that we're going to be working on. So let's go ahead and look at what the requirements are for the lab. So the first task is configure a VRF in R2 and R5 with the VRF VPN-A with this route distinguisher and these two route targets. And assign R2 and R5 to the links VRF. Okay, on the link. So on R2 and R5, the links going down to our PE, which is going to be 8 and 1. Let's look back at our diagram. It's going to be 8 and 1 on those two links. We're going to need to add that VRF to that interface. That's for the first task. Second task is we're going to create another VPN on R4 and XR1 and then assign those route distinguishers. And that's our XR1 and R4. That'll have VPNb. Alright, and then configure EIGRP AS1 on the links between the PEs and CEs and advertise the loopbacks into EIGRP. Alright, seems pretty straightforward. And configure BGP on R2, 3, 4, 5, and XR1. And the way we're going to do that is we're going to use BGP AS100. Our device should appear with R3 via IBGP, so R3 is going to be our route reflector, just as it here at the bottom. And then use the loopback interfaces for the BGP source, and then redistribute BGP between the VRF or EIGRP process and the PE routers. Once complete, R1 should have reachability to all of R8's networks and vice versa, and R2 should have all of access to all of R7's networks and vice versa. Perfect. This is pretty straightforward. I'm not gonna do that. So this is a pretty straightforward lab. Didn't mean to click that button there, but so we could do this pretty fairly quickly, I would assume. So what we're going to do is we're going to configure the VRF on R2 and R5 first, and then we're going to configure the VRF on R4 and XR1. We'll do it in order as far as the steps are concerned. I have a different approach normally. After I read the topics, all the stuff that I know that I can dump straight out on Notepad, I'll go ahead and do. Um, so I'll just show you guys how I normally do it, and then make sure I hit the task. INE used to have the ability that you would be able to X out the what you're working on as far as the task. I don't know why it's not doing that anymore, but anyway, it used to be an awesome little feature. So let's get started. So on R2 and R5, we're gonna need to do VPN A, and then it's 100 route target 101, and then the route distinguisher 101. So that's pretty straightforward. Let's go ahead and pull up the diagram and let's run it. So R2 and R4 needs to have VPN. So wrong router. Let's go to R2. So show IP interface. Don't need to do this. So router. So I don't know if you guys hear my new keyboard in the background. It's clickety click click, but it's mechanical. I love it. It feels great on the fingers. My wife isn't gonna be a big fan of it, but hey, it is a awesome keyboard. So what we're gonna do is do VRF definition called for VPN-A, route distinguisher 101, route target both 101, address family IPv4. Show run section VRF. What am I looking for? VPN What did I call that? Did I not name that VPNA? Did I see? So run section. So we're just going to take this and we're going to copy this onto router 5. That's what the instructions said, right? It sure is. So router 5. Do the same thing. Boom. So, and it says assign the links that are going to the R1 and R8 respectively to their VPNs. So let's go back to the diagram and let's look at the link between, oh, change the diagram, it's not the right one. Okay, so in R2, he's connected to R1, so we're going to go to that interface, 1.12. So let me do a show run interface gig 1.12. So we'll do a show VRF forwarding, VPNA, obviously IP addresses get wiped out. I'm going to take that back on. Good. And same thing with R5. About 58. Show run interface gig 1.58. And then VRF forwarding, VPNA. And then reapply the IP address to the interface. Boom. That's good. So we're going to do the same thing on, I believe, R4 and XR1. So we're going to do VPNb. So let's go ahead and do R4. We can actually take what we had from R5 and just change it up. Oops. Looks like we're going to have to do a show run on that. So we did it over here already. So we'll just take this. So we're going to call this VPNb. The route distinguisher and the route target's going to change. 102, 102. So we'll put that on router 3, I believe. I hope that didn't just open. Put that on router 3 and or router 2 and router 4 and router XR1. So on router 4, go ahead and configure that there. And then looking at the diagram, he's connected to R7. Run interface gig 1.47. Interface gig 1.47. VRF forwarding. VPNb. Let's reapply the IP address there. Good to go. And then XR1, which is right here, going between that and XR2. So we're going to go ahead and do a couple things here. So there's two steps for creating the VRF and XRs, iOS XR. First, you create the VRF, VPNb. Specify the address family, unicast, and then we do export route target, then 100:2, and then import route target 100:2. You just commit that. IP interface brief. Do show IP brief. So we're gonna need to assign the interface 1920 between. So iOS XR is a little tricky when you're doing this. Just to show run interface on that. And then we go to this interface here. First, we're gonna have to take off the IP address and then commit, and then add the VRF VPNb, and then commit, and then we're gonna re-add the IP address, and then commit. Cool. So show route, and just to do a quick verification, show route VRF VPNb, which we have a connected interface. Router 4, show IP route VRF VPNb. B, which we have a connected route. 2, show IP route VRF VPN A, which we have a connected route. And we take that show same command and we go on router 5, which it had this connected route. There's still a piece on XR1 that still needs to happen, but since we haven't gone there in the steps and I said I was going to go in order, we'll do that piece, but that's for configuring the BGP. But so let's look at the next step. So we got these two steps configured. Let's go ahead and do the EIGRP between the PE and CEs. So we'll just go to router 1 first and then do hits EIGRP process. And we can use name mode, we can use the regular mode EIGRP since it doesn't specifically say. We'll just use whatever. So we'll just do router EIGRP 1. Let's make sure that's the AS that it wants us to use. Yeah, AS1. Okay. So router EIGRP AS1. No auto summary is already there in iOS 15. I just make that a habit. And then we'll do our network statement. So we'll do network 1.1.1.1.0.0.0 for the loopback address. And then we'll do a network 10.1.2.0 0.3. Or actually it's 255 because it's a slash 24, but it doesn't matter. So we'll do that. And so EIGRP is running there. And then on router 8, let's do the same thing. Actually, we'll do router EIGRP1, and then we'll network. Ooh, wrong router. EIGRP1. We're supposed to be going to router 8. And then we're going to do a network 8.8.8.8. Network 10.5.8.0. No auto summary. And then we need to do the same thing for router 7. Router EIGRP1, network 7.7.7.7, and then network 10.4.7.0. And that's good. And then we are going to XR2, who needs it as well. Router EIGRP1, address family IPv4 unicast. And then we specify the interface, which is 000.1920, and then interface loopback 0. Commit. So all the CE routers now have it on there. So we should be able to go to our PEs, which would be 2, 4, 5, and XR1. So let's go to our PE routers. So we're going to start at router 2 first. So what we need to do is do our VRF aware process. So we'll do router EIGRP1, router EIGRP, we'll just do name mode on this one. PE, address family, IPv4, VRF, VPN, VPNA, autonomous system 1. Perfect. And then we do 10.1.2.0, and that should bring up that process there. We have a new adjacency, and let's go to 4 and 5. Router EIGRP CE, and we'll do address family IPv4 VRF. I believe 4 had VPNb, autonomous system 1, and then network 10.4.7.0. EIGRP should come up there. Perfect. Same thing with router 5. Router EIGRP CE. Autonomous system 1. Network 10.1.5.8. 10.5.8.0. That should be good. And now for XR1. router EIGRP CE, and then we're gonna do VRF VPNb, address family IPv4. We're gonna name the autonomous system as 1, and then we're gonna do interface gig 000.1920. And that should come up here. Show EIGRP neighbor. Okay, so we got EIGRP up. Let's show it on his side. I didn't turn the logging messages on iOS XR. EIGRP VRF on. Neighbors. So we got neighbors up. So that's good to go. Everything looks fine. So let's go back to our task. And I'm doing this pretty slow. Normally I would kind of blaze through this. This is a pretty simple configuration, but I'm just kind of slowing it down and walking through just to make sure that everybody's on the same page on what we're doing as far as each step that's happening in the network. So this command, this is done, and this is done. Now we're on to this step here, and we need to do the BGP. So the BGP is probably the easiest part. Once you do it on the route reflector, just take the route reflector's configuration, modify it, chop it, and every PE after that will have the exact same BGP configuration. And I'll show you what I mean here. I use templates. I'm very template driven when it comes to my BGP config, so I'm going to create templates on the BGP. So since router 3 is my route reflector, I'm going to go ahead and just do my route reflector configuration first. So, well, we'll do our route reflector client configurations. So in that particular case, the clients in this network is going to be 2, 4, 5, and XR1, and they're going to pair with router 3 as a route reflector in the network. Even though router 3 has no VPNs configured, there's going to be a command that you got to put in there to allow router 3 to reflect the each VPNs between the PEs. So I'll show you guys that last, but we'll do the actual PE sites first. Oops, go back to our config. So let's start with router 2. So back on the instructions, it says to use AS100. All devices should pair with router 3. Loopback 0 should be the source, and then redistribute between the VRF where process. Easy. So let's go ahead and do that. So on router 2, router BGP 100, and then we'll do no BGP default IPv4 unicast, which that command, it disables the address family IPv4, the AFI SAFI of IPv4 unicast to automatically come up. At iOS, that's the default, so you can disable that if you're only going to be running VPNv4 sessions, which we will be doing in this example. So first thing is we're going to create our template, peer session. We're going to call it IBGP, and we're going to call for remote AS is 100, and then update source is loopback 0, and then we're going to create, we don't really need a policy on this one. We don't need a policy. So what we're going to do is we're going to do neighbor 3.3.3.3. We're going to do inherit peer session IBGP address family VPNv4 neighbor 3.3.3.3 activate. Do shall run router BGP, and you know what, just for the hell of it, and then we should do address family IPv4 VRF VPNA redistribute EIGRP1, and that's good. Shall run section. So we'll just go ahead and copy this. So the other router that has VPN1, I believe, is router 5. VPNA is router 5. So we can actually take this exact configuration and just throw this on router 5. Okay. And then on XR1 it's going to be different, but on router 4, we just got to make some modifications to that existing configuration. So instead of VPN A, you're going to be B, and that's all we need here. So let's go to router 4. Right. And then on XR1, I love the configuration for XR1. It just makes so much more sense. So got to activate the address family that we want to use, which is a VPNv4 unicast. We're going to specify our neighbor, which is going to be 3.3.3.3. Remote AS is 100. Update source is loopback 0. And we're going to activate that neighbor under, activate this address family under the neighbor. So this is what it looks like so far. This is the configuration looks like so far. And then the next thing we're going to have to do is get out of the neighbor, and we're going to have to go to VRF VPNb. We're going to have to specify the route distinguisher here, which is 100.02. And then we're going to activate the address family IPv4 unicast. And then inside of that, I think we do the redistribute EIGRP CE. Did I call it CE? Let's do a show run real quick. Show run router EIGRP. And I called it CE. So we're going to redistribute EIGRP CE. And commit. Sweet. So this is halfway done. So the next thing we're going to have to do is configure the BGP session for router 3. So we're going to call this session is going to be BGP. And then we're going to take this peer session and we're going to do a template, another template. So all this could be the same. Actually, let's go to router 3. And we'll just create our template names now. So router 100 template peer policy IBGP route reflector clients. So route reflector client, that's all we need. BGP template peer policy route reflector clients. So you want to take all this here. Okay, so what we're going to need to do is we're going to need to create neighbor statements for 2, 4, and XR1. So 2, 4, 5, and XR1. So 2.2.2.2 is 1. Oops. So you got 2.2.2.2, then you have 4.4, then you got 5.5.5.5, then you got 19.19.19.19.19. Perfecto. And then under this guy here, we're going to have to do this for each neighbor. So 2.2.2.2. We actually don't need to do this command. That automatically gets added in when you're activating a VPNv4 session. So don't got to worry about that. Uh-oh. So we're going to take this. We're going to do it 3 times. 1, 2, 3. We're going to do 4.4.4.4. 5.5.5.5. 19.19.19.19. Alright, and we'll just copy all this here. And then we have, let me just copy this here. take this here. And that's all we need. So that's good. And we're just going to take this half of the config and add that to our BGP config on router 3. And that should take everything perfectly fine. And we should start seeing sessions coming up. So 5 just came up, 3, 4, 2. So I'm pretty sure we should have all our sessions up right now. So BGP all summary. So we have an open sent and 19's up now. And we should have prefixes learned. So there's one other step that we're going to have to do. Did I not advertise? Let's see. Maybe it's taking for a second for router 19 to send his routes. Let's look at router 19 show run. So run router BGP. Okay, so it's there. Maybe it just took a second for it to advertise. Huh. You weren't 7. I wonder if I need to set the, let's check this out. Verify why we're not learning those routes. iOS sometimes, man, iOS XR sometimes it gets tricky. You know, there's certain things that you got to do as far as when it comes to redistribution, IPv4 unicast. So let's make sure that redistribute, yeah, grp CE. Let's do a metric because it might not be. Advertising the metric. Let's see. Hmm. Why aren't you? Show route. So he's learning router 4's route. So why aren't you advertising those routes? Let's see here. Come on. Shouldn't matter. That's weird. Make sure that my show run BRF. Let's see what's happening here. We got VPNv4. So show PGP VPNv4 unicast neighbor. Wow, this is really odd. I don't know why we're not advertising that. Then BGP. iOS XR, man. I'm pretty sure there's something that I'm missing here. Show one router. BGP. We don't need to do the metric. The CE should be automatically. Hmm. So why aren't you advertising that out? So the route. Let me see if it's because I'm not doing the route target filter. Let's see, router. And this is a command that has to go in order for the routes to be propagated that are not configured on the BGP route reflector. We want to disable this. Let's see if that works. Yeah, for some reason XR1 is not redistributing BGP GRP. He's exporting it, but he's not importing it. Let's see here. It's a VRF VPN. Address family IPv4 unicast. Redistribute EIGRP CE. That's weird. Oh, I know what's going on. Show one router. No, it's there. VPNv4, it's good. His IPv4 is there. Because I wouldn't be learning his routes. Let me see if I need to create a route policy. I shouldn't have to. Uh, EIGR. What we kind of call it? Pass. 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 Router BGP 100. Address family. No. They go VRF. VPN B. Address family IPv4. Unicast. Redistribute EIGRP. CE. Route policy. Pass. BGP soft. Why aren't you restricting any routes? Show route VRF VPN B. He's learning route in 20's address. When I redistributed that, that should have came out. I wonder router EIGRP. let's clear out this EIGRP no router. Let's see if I need to just do it by the. We'll clear that out. So commit. So we'll do router EIGRP1 VRF VPN B. Address family IPv4 interface gig dot 1920. And let's do a quick show. Show router VRF VPN B. Yeah, GRP has not recovered yet. Neighbors. So this is kind of driving me crazy right now. Why isn't this coming up? Hmm. That is super weird. Hmm. What the heck is going on here? Hmm. This is a little annoying right now. Let's see why I cannot get this to work. Just family gigabit 0001920. Verify back on the diagram. That's it. That's, didn't have that there. Okay. VPN B. Shouldn't have to put an autonomous system. Yes, I do. Let's see. Okay, so that's good to go now. GP. So we're gonna take this off. And then we're gonna redistribute EIGRP1. And now, I don't know what the heck that was about. That was weird. Like I said, I should have redistributed earlier. I don't know why that did that way. Must be something with the EIGRP with iOS XR. So sorry for wasting all that time, but that should have came up at the exact same configuration. Show one router EIGRP. I mean, the only difference is that I'm naming the autonomous system number here opposed to putting the process name. So that was really weird. Anyway, so let's keep moving. So when we go and redistribute, so we need to redistribute BGP into EIGRP as well for this to work. So let's go to all our respective routers. Show PE routers. So run section router EIGRP, and we're gonna take this here, and we have to topology base redistribute BGP 100. We shouldn't have to set a metric. Let's just double check that. If I redistribute that, router 1 should get those routes now. So EX. Yeah, it is working. Okay, so yeah, I didn't actually have to put the metric. I shouldn't have to actually. So we did that. Let's go ahead and go to show run on router 4 section. We can verify this. So router 7 should not be learning any routes right now. But if I'm router 4, router EIGRP, let's go back to our diagram. So we're logged into router 4 here. We verify that 7 is not getting any routes now. So if I go into this config, and then we do a redistribute EIGRP 100, or sorry, redistribute BGP 100, and then router 7 should start learning his routes. Perfect. And then same thing with router 5. So run section router EIGRP. We go into this place here. Da 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 da. Config T. Redistribute BGP 100. Perfect. And then an XR1. Router EIGRP1. And then we're going to do VRF VPNb. Address family IPv4. We're going to redistribute BGP 100. Perfect. And then commit. And so he should be learning EIGRP routes. Perfect. So now that is all completed. We redistributed between BGP and the VRF aware process. We got all the VPNv4 clients set up with our route reflector, which is router 3. Um, Pretty much all the tasks are completed. So now we just need to do our verification. It's just to say now that R1 should have reachability of to all of R8's networks. So if we go to R8, let's go to R1. We'll pull the diagram up, and then we'll go to R1 because both R1 and R8 are in VPNA. So if I log into R1 and I do a ping to 8.8.8.8, I have reachability. And if I do a ping to 10.5.8.8, should have reachability, which is this interface here. So we got bidirectional communication within VPNA. Now let's see what it says to check on what XR2 should have reachability to all R7's networks. So let's go to XR2. Go to XR2 here. And XR2 should be able to ping router 7's address, which is 4.7, and its loopback. So we'll ping 7.7.7, which it works. And then we'll ping a 10.4.7.7, and it works. So this lab is completed. We can go through and verify and look at our configuration to compare it, but I mean, it's pretty much the same. Let me see how they did their XR1 configuration for EIGRP, because that should have automatically redistributed when I did that earlier. I don't know why that was doing that. EIGRP. That was really weird. So let me look at his BGP config. Redistribute EIGRP1. Ah, I think because when I did that configuration earlier, I didn't assign the autonomous system number, and when I did the redistribution, I was doing it based off of the process ID, not the autonomous system. So that was my mistake. This is why it's working now because I did the autonomous system and the process ID with the same exact identifier. So that makes sense. So it was a mistake on my behalf. I just did the redistribution command and did it on the wrong EIGRP reference. I did it on the process ID rather than the actual autonomous system number, but was able to quickly figure that out. So it wasn't that big of a deal. And so what we're gonna look at is let's check this out in the control plane. So with router 3 being the route reflector, what's going to happen is that all the routes, so notice if I do a show IP VRF, you'll notice that no VRF exists in on the router 3's interface. So the command that I configured on here, this one here, show run shin router BGP, the command that I configured, this where is it at, no BGP default route target filter. Now what that does is that if there's the VRF does not exist on router 3, it would allow it to learn the routes and then propagate it out to any X and any um PE that has that VPN configured for it. So like router 3 is able to reflect router 1 and XR1's or router 1 XR5's IP addresses or their prefixes because he is able to look at those route targets. And the way we can verify that is just to do a show BGP VPNv4 unicast, and instead of doing route target VRF, we do route distinguisher, and we'll do 100.01, and you'll see those are the routes coming there, and then 100.12. Those are the routes coming there. So we can validate that. And you notice that the next hops are still going to be the PEs of who originates those routes. So the next hop is still going to be 4.4.4.4 for router 7's addresses, and then 19.19.19.19, which is XR1, for router 20, which is XR2's addresses. So that those stay the same. As we know, route reflection, it works the exact same in VPNv4 as it does with VPN with IPv4 unicast, where the route reflector will not modify the next hop when sending it to its route reflector clients. So we can also look at this from router 2's perspective. If we do a show BGP VPNv4 unicast, we'll just do VRF VPNA. You notice that it's only in the control plane. So if I go to look at this route that we're learning, well, that's coming from router 1. We're originating that. We're going to do router 5, this one here, or we'll do it based off of router 8's loopback address. So if I take this same command and I looked at this, what you're going to see is that we're going to have another entry inside the BGP update packet, which is going to be the cluster list. The cluster list is derived from the originator ID, which is the which originates from the loopback address of the route reflector, and this is just for loop prevention. So I can verify what route reflector this is coming on if I have dual route reflectors and I have them reflecting between each other. Um, each time this update goes through a route reflector, it updates this cluster list. So this is a way to verify that you're getting it from your route reflector. The originator is going to stay the same because the originator of this actual route is router 5. And you need this because if this it changes to router 3, what would happen is that when it tries to forward packets, oops. So what would happen is when it tries to forward packets, it will do it based off of, it would try to do it with router 3's IP address. And since router 3 isn't actually participating in the VRF, a BGP VPN v4 label will not be established and your LSP would break. So traffic needs to forward to the actual endpoint, which would be the other PE, which would be router 5 in this case, in order to trigger the L3 VPN label. And you'll notice that based off of here, the label that router 5 self-originated for his route to router 8's loopback address is label of 20. And so this is what you're using for the VPN v4 label, and then you'll have your transport label that gets you through the network. That LDP is handing over to router 2 via, I believe, router 6 he's connected to. Let's look back up. No, router 3. So you can take two paths. You can either go out of router 3 and router 4. You can do ECMP. You can do either one. I mean, there's a number of ways that you can traverse this, but that's the most important thing, is that when doing the VPNv4 route reflector design, you need to make sure that the originator is the actual far end PE address, and that the cluster list is being updated. Either you do cluster list, or you create a uh oh man, I forgot the name of it. The originator ID, where you can do cluster groups, and configure a loopback between different hierarchical design for route reflectors, so that way a group of route reflectors can share the same cluster ID. It's just a bunch of different design options that you can do, but this is how we can verify that the VPN v4 updates are coming from the right route reflector, or if there's an issue in the control plane, or if there's an issue with the forwarding plane, what's happening. So just keep that in mind. All right, well, that was that lab. I'm glad you guys were there to experience the heart pain with iOS XR, and my mishap could have been done a lot quicker if I would have just caught that mistake earlier. But it is what it is. All right. Well, we'll move on to the next lab. We'll do this in the next video. So in this particular lab, it's going to be doing route reflection with iOS XR, which means that in this particular case, iOS XR is actually going to be our route reflector client rather than our iOS XE box, which was router 3 last time. So, alright, in the next video, we'll go on and continue with that. Thanks, guys.